Everyone, today we're going to be looking at matrix equations and how to create them and maybe what they're useful for. In this homework assignment, you just have to create the matrix equation, but I think I'll go ahead and show you what they're really used for as well when we're done here. So a matrix equation is nothing more than an equation using matrices, right? So you can see here we have a matrix of numbers, we'll call that matrix A. And then you have a matrix of variables, and that would be multiplied together, and that's going to be equal to another matrix of variables, or numbers, sorry. So numbers, variables, numbers. And we've got a 2 by 2 or a 3 by 3. The size kind of depends on the number of equations and the number of variables you have. So if you have a system of 2 equations with 2 variables, like linear examples, it's going to end up looking like this. And if you have 3 equations with 3 variables, x, y, and z, then it'll be a little bit larger, okay? So if you do have 2 different equations with the same 2 variables, like these are linear equations, then we can convert this to a matrix, a single matrix equation, by taking the coefficients, A, B, C, and D, the coefficients, and creating our 2 by 2 matrix. The next matrix with the variables are just x and y, okay? And then the last one over here equal is the numbers, the constants, E and F, okay? So, one more time, these are the coefficients. Then you've got, oops, I didn't spell that right, coefficients. Coefficients, and then you have the variables, and then you have the constants. Okay? Now you'll notice that originally these equations are in standard form. It's kind of critical there. Standard form is where you want to start with. All right, and then you can convert those pretty easily into a matrix equation. So this is what a 2 by 2 looks like, or a 2 equations and 2 variables. And this is what it would look like if you have 3 equations with 3 variables. Now that's usually only dealt with in like 3-dimensional geometry, x, y, and z, if you have a z-axis. But nonetheless, there you go. You got your coefficients A, B, and C here. Your variables x, y, and z written in a column. And then your constants on the other side of the equation also written in a column. All right? Pause the video if you want to take a little bit longer look at that. I'll move on. All right, so here is our first example. We want to convert this into a matrix equation. And so I'm going to have a matrix of coefficients 2, -3, 1, and 5, right? Because that's a positive 1x and that's a negative 3y. And then we'll create a matrix of variables, which are just x and y. And then on the other side of the equal sign, we'll have a matrix of constants, 7 and -6. And there you go. That is how you convert a system of linear equations into a single matrix equation. All right. Here we have a little bit larger one. So 3 equations, the same 3 variables. If we convert this into a single matrix equation, we put all the coefficients in 1, so this is 1x, 1y, and -2z. The next equation is 3x, -1y, and positive 1z. And the last equation is 2x, 5y, and -3z. So all of our coefficients go in the first matrix. The second matrix here is going to be the variables, x, y, and z. And the third matrix is the constants, 6, 7, and 8. Okay, so that's how you do your homework. Now, let me give you a little bit extra. Even though we don't have to cover it in this section or in this course, matrices are very powerful. You can solve systems of equations using a substitution approach, you can use the elimination method, or you could even use the graphing method, okay? But my favorite is the matrices, because there is a way to solve a matrix equation, okay? So let's just say that this is matrix A, times our variables equals matrix B. And if I want to solve an equation, right, if I had 3x equals 9, then I would just divide both sides by 3. That would eliminate this number, and I can calculate this one on the other side of the equation. Same kind of stuff works with matrices, except it's not really division. It's multiplication by an inverse, which we have talked about. So you'd have to find the inverse of this matrix, and you'd have to multiply it on both sides of the equation. So these two would cancel each other out, and you would be left with just your variables. And on the other side, you'd have to multiply matrix A times matrix B, or the inverse of matrix A, okay? And there's a way we can do that by hand, but there's an even faster way we can do that on the graphing calculator, okay? So I'm going to show you my calculator real quick. Let's get rid of that. Okay, so right here in blue, it says matrix, right there. And so we're going to hit second and that button, and we come up with this nice little screen here. We're going to go over to edit, and I'll put my 2 by 2 matrix. You do have to enter the dimensions and all the numbers. I'm hitting enter after each number I enter. So 1 and 5 there. Okay, so I've got that matrix there. I'm going to hit quit because I inputted a matrix. Now I'm going to go input the other matrix as well. Go over to edit and then go down to the next one. And this one has 2 rows but only 1 column. Okay, so you put your order or your dimensions there, and that'll kind of help you start creating it for you. All right, so now I got those in there. I can quit. So what I've just done is I've taken my numbers that are on my paper here, and I've put them into the calculator. Now what I want to do is multiply the inverse of matrix A. So I'm going to grab the name of matrix A, and that little button right there is the little -1. That's for the inverse. And then we're going to multiply it by matrix B. So just like that, and it's going to spit out our answers for the variables. Now I can actually go ahead and change this to a fraction, I think. Yeah, there we go. So that's telling me, oops, come on back, calculator. Let's see. Always in front, that's what we want. So that tells me that the x is going to be 17/13. That's the number on top. And the y variable is going to be the number on bottom, -19/13. And just like that, we've solved this system of equations. Now, with a linear system, it's not that difficult. But if you have a much larger system, all right, it takes a little bit more on paper, okay? But on a graphing calculator, check this out. I can create a 3 by 3 matrix, and let's see, 1, 1, -2 is the top row, 3, -1, and 1 is the middle row, and 2, 5, and -3 is the bottom row. So I've created this matrix in my calculator. Now I want to go create the other matrix. We're going to go to edit matrix B. This is a 3 by 1 matrix, so it is kind of important to know the dimensions. 6, 7, 8. All right, so I've got that one created. And again, what I want to do is A inverse times B. And there you go. And just for the fun of it, we'll change these to fractions as well. And that's how quick and easy you can use a matrix equation to solve a system of equations. These numbers represent our variables. Okay? Now, if I had done this by hand using the substitution method or the elimination method, it might take me a half a page to a full page of algebra to get this worked out. But with the graphing calculators, if you have a matrix equation, you could just type in the 2 matrices, bippity-boppity boop, you've got your answer. Kind of nice, huh? Alrighty, if you ever take a class called linear algebra, you will definitely be dealing with some matrices. Okay, but that's a college level course at UCA, linear algebra. Think about taking it. It's a lot of fun. All right, see you later.